So my name is Ian Howard. I'm going to teach you on this AINT351 machine learning course about machine learning, and today we're starting off with an introduction to the course. So what are the aims of the module? Well, the aims basically are to introduce you to the area of machine learning, so what is machine learning, and various different breakdowns of what it covers, such as unsupervised learning, so we've got some data and we don't know anything about it. We've got supervised learning, so we've got some data and we know basically what labels or outputs it relates to. We've got to learn them with another network or some system, so we can then automatically do that. And then things like reinforcement learning, where we're learning how to behave, if you like, when we're in a certain situation. So we know, we want to learn the appropriate action to take. And we'll look at this really from more of a probabilistic perspective, but also from the perspective of optimization and gradient descent. So the aim of this module then is to give you a range of techniques so you can actually go away and actually analyze data and build systems that can actually classify, make decisions, maybe predict values, as well as systems which can actually optimally generate actions when they're in a certain situation. So this will enable you to analyze some real data, and also, if you wanted to at some stage, you could also build these things that work in real time. Now, the important focus of this particular module is on the principles, the first principles of how all this works. So going through all the little tiny details, getting you to build things from first principles in MATLAB. And I'm not going to touch on some of the latest developments or the latest fashionable things that have come up, although, of course, there's some really big breakthroughs making here from time to time, but we really need to understand the principles. Also, the latest fashionable stuff changes every month, although, the principles will be the same probably, well, certainly in 100 years from now, because, a matrix is a matrix and gradient descent is still going to be gradient descent. So learning outcomes. Well, the important thing about this course is to make sure that you end up with an understanding of basic concepts of the field of unsupervised, supervised and reinforcement learning, and make sure you can demonstrate that you can actually take some of these techniques and apply them to make decisions or build classifiers or build systems that make predictions using real data, and maybe at a later stage actually to be able to build things which actually control things as well in real time, say. So there's lots of books out there on machine learning. Here's just one example, Machine Learning, A Probabilistic Perspective by Kevin Murphy. You might even be able to get it online. There's lots of books out there that you can get as PDFs these days. A particularly good book for reinforcement learning, so the first book is pretty much for every aspect of machine learning. Something more specific for reinforcement learning is the Sutton and Bartow book. You want to get the latest edition. You can also get that online as a PDF, so you don't have to spend any money. This is a really nice book on reinforcement learning. You want to get the second or the latest edition basically because they change the nomenclature, so how they actually write things down changes from the first edition to the second edition, and this is kind of using the way of describing things in terms of conditional probability representations and things like that. So it's a much cleaner way of actually describing what's going on. So I definitely recommend that. So again, look at the suggested links that I've put on the DLE as well. Now, I personally like watching YouTube videos a lot to learn stuff these days, and there's masses of stuff out there. I've put a few links in, but there's it keeps going up on a daily basis almost. One of the reasons I think this is a great way to learn is because institutions like MIT and Stanford in the US put lots of their stuff, not maybe all of it yet, online, but lots of it's online, so you can work. You can really learn from really expert people, and obviously they've got really great production facilities at some of these places, so they do some great videos. So to be honest, looking at YouTube videos and as a nice way of learning stuff is also kind of my inspiration for actually recording screencasts for you, because it gives you also the opportunity, if you don't understand something the first time round, or I'm speaking too fast, you can just go back and listen to it again. And that's something I do a lot on YouTube videos, right? If I'm learning a new topic, I'll go find a YouTube video by someone who hopefully knows what they're talking about on YouTube, and watch it maybe several times until it finally clicks that yes, I can understand that. So let's have a rough overview now of the lecture schedule. I'm assuming that you kind of know MATLAB, because you did use it quite a lot last year in control engineering and in robotics. Some of you did robotics as well. There's lots of information on the control engineering DLE site from last time. So if you didn't do all the practicals in MATLAB, you can go back and have a look. Again, I might do some revision on MATLAB as screencast for this particular module as well, but I'm not going to do them straight away because I haven't got the time. The lectures are then going to follow roughly the following schedule. So we're going to start off with just a vague, broad introduction to machine learning, talk about data sets. This data is basically the stuff that we need in order to learn stuff from and build systems from. Starting then with, how are values of parameters and measurements, how do they distributed across value, and how do we then pick certain samples from a certain distribution and such like. Then we're going to talk about an important technique, which is basically gradient descent, and this is to do with how do we find the minimum of a function. So we have to define what we want to actually minimize, and normally it's like some sort of error. So we want to build a system that fits the data very well, and when it's fitting badly, the error is big, and when it fits well, the error is really low. So we can use techniques like gradient descent. We basically change the parameters in such a way that every step we take, the error goes down, and this is basically a form of optimization. And we'll discuss that as well. A very important topic. We'll then start off with a very simple, if you like, machine learning technique, which effectively is a linear technique to basically fit data with a linear function. Simplest example would be fitting a line to a data set. So y equals mx plus c, that kind of thing. How do we fit the line to the data? Then we're going to start moving forward to how do we actually classify stuff. So imagine you've got some camera taking pictures of things. How do you classify things into what's on the picture? In a simple example, it could be that you're doing a classifier for fruit. You want to know if it's an apple or an orange or something like that. The important thing is we've got the data coming in. You know the label of it, and what we want to do is we want to train a system to automatically be able to also classify stuff and regenerate the labels that it's seen during the training data, and then use it on real data, of course. Then we're going to introduce reinforcement learning. So this is slightly different than linear regression pattern classification. So both of those techniques are what we call supervised. So what I mean by supervised is you've got the input data and you know what it should be, and then you get your machine learning algorithm to do that automatically. What reinforcement learning does is it builds something called an agent. And an agent's it could be like a person. You can think of a person as being an agent. But basically the idea is you've got this agent which will be in certain states, and it has to make appropriate actions, and it's got to learn how to do the right action to get the best overall reward. Then we're going to look at things which are actually goes under the umbrella of unsupervised learning. So we don't know anything about the data, the fact that we've got the data. We don't know anything about it. It's just some measurements coming in. Can we say something about the data just on the basis of what we've got without knowing anything else about it? And we can, as it turns out. We can start clustering it into things that, things that look similar can be associated together. And we can also re-represent the data using things like PCA, which is principal component analysis, and do it into a more appropriate representation sometimes. Then we'll move on to quite a big topic in this course, which is neural networks. In particular, we're of particular interest, of course, to multi-layer networks. You can only do so much with one single layer. So we look at that. We'll understand how to actually implement them, how to actually understand the training, and implement the training as well. And multi-layer networks feeds then into the area of deep learning when we've got lots of layers. So a multi-layer network might have 3 layers typically, but deep learning could be up to, it could be 15, 20 layers even. So we'll touch on that as well. But again, more from a theoretical perspective. We won't be diving in with the latest TensorFlow or Python implementations in Keras or stuff like that. That's something that you can do yourselves. That's something that also doesn't really require you to know very much about machine learning, because you can just use these things off the shelf and they'll work really well. But in this course, I want you to learn stuff from first principles. Then we're going to move on to a couple more areas of reinforcement learning. So how can we actually learn how to make actions just on the basis, if you like, of random exploration or pseudo-random exploration. And then temporal difference learning is an extension that we can use as well. Then we're going to look at some specific methods which actually, rather than learning the value, they directly learn the action from while they're going along. And one of these is SASA. Another one is, the famous one is Q-learning. And then we'll also look into things like a functional approximation. And the idea of that is, whereas most of the stuff we're doing on this course with reinforcement learning is going to be on the basis of tables, when you get really big dimensionality spaces or continuous problems, you can't use tables anymore, and you need to use a function, and that could be implemented with a neural network. So in addition, I will give a bit of an overview of the coursework when it's appropriate, and right at the end we will go through some exam questions. Okay, assessments. So assessment will be in the form of coursework, which is 50%. Coursework will also be released about a month after the start of this course. Obviously, I need to cover enough material so you can get started in it. So that's really the critical issue. Is I can't let you have the coursework too early, because I don't want you starting stuff before you've actually heard me talk about it. It will need to be submitted before Christmas, and I think the 17th of December is a good date for that. That's about as late as I can leave it in this particular region of time before we have the Christmas break. That's going to be done by 1600 hours onto the DLE. I'll try to get feedback within 20-ish days, 21 days or whatever it is. There will also be an assessment in terms of an exam, but it won't be a normal exam anymore because of COVID, we're having to do these coursework in lieu of exam things. So that will be sometime in January, and that will be 50% of the work as well, so 50% of the mark. But don't worry, we will go through exam questions before you get to that stage. The reason for actually letting you have the coursework then early and getting it in by the end of this particular year, rather than going over the Christmas period also, is that means you can concentrate after that just on practicing exam questions. So hopefully that makes things a little bit easier. Coursework assessment, well, always submit only as a PDF. I can actually set that as a requirement on the DLE now, and DLE is where you'll be submitting. When you write a report to answer the questions, so their questions will be in the lab sheet, the coursework sheet. I do always ask specific questions. Please answer them if you want to get marks for them. But when you're writing your report, I'd like it to be done in such a way that you've got your student number on every page. I'm going to give you a template for this, but also put your student number in the file name as well. You're not supposed to put your name on it because it's supposed to be done anonymously. Obviously, there's, to what extent it's going to be anonymous. I don't know your student number and I won't learn them off by heart, so I'd suggest that's a good way of doing it in a pseudo-anonymous way. It's always dangerous as well if there's no information at all who wrote what. I find it really difficult sometimes to work out where am I supposed to be uploading this to after I've marked it, because I don't know who, it doesn't say on it who it is. Then I have to backtrack and find out by looking back at the DLE, and it's a bit of a mess. So it's much, much better and safer if you put your student number on every page. When you do actually do your coursework, you'll be asked to show things simulate things and show them working. Generally, the nice way to do that is to do YouTube video and then put the link into the report to show it works. Now, please check that your YouTube videos work. And make sure that they work when you're not on the same machine that you uploaded it in, because quite a lot of the time I get links. Well, first of all, they could be to private accounts, so I can't access them because of that, or they are linked to a file which is actually on your hard drive and I can't get access to that either. So always check if possible, from another computer, and preferably as another user that I can actually use these things. Also, when you're uploading your coursework, please make sure that you've checked that you've actually uploaded what you thought you have, rather than something with it's completely different. As always happens a couple of times a year as well, I get somebody uploads the question sheet or something like that, right? Rather than the report, right? Always use the correct format. These are things just to make my life a lot easier if you do all of these things. Practical sessions. Okay, so there's going to be practical sessions once a week. I'm setting up tasks for you to do, which will basically reinforce your theoretical understanding of important issues. Now, these won't be marked. They're just there for your benefit, right? Just for your benefit. And, for example, you'll be starting off with building stuff which generates distributions and plots out histograms and all this kind of stuff. And so on, and you'll move on. Just to give you a very, very brief overview then of what the sessions are going to be. First one will be something on 1- and 2-dimensional distributions. Second one is on linear regression. Third one is on a linear classifier. Again, all of this stuff you'll be doing from first principles. Fourth one will be on Q-learning. Fifth one will be on naive Bayes, which is basically building a classifier using probabilistic concepts and modelling things with Gaussians. Sixth one will be a clustering algorithm, one of the simplest algorithms actually, k-means. Then we'll start hitting a bit more reinforcement learning, so dynamic programming, policy and value iteration. The eighth one is going to be Monte Carlo and temporal difference. And the last one will be looking at things like SARSA, DynaQ, POMP, DP. So various other techniques in reinforcement learning, which are very useful to know about. Again, all of these things are very basic concepts, but things have moved on a huge way since the first people did simple reinforcement learning. But again, if you can understand the concepts, then you can understand these new algorithms very, very quickly. Module delivery. Well, we know that COVID is a bit of a pain and we can't go in most of the time, or certainly we can't all go into the same lecture hall, so I've decided I'm not going to go in at all. So let's just scrub that, and I'll just do a Zoom lecture during the time that we're supposed to be normally in the lecture hall giving a lecture. I think that's quite a good way of doing it. I'll certainly do that. I'll also have Zoom lectures.
I don't know that one.
We'll also have Zoom lecture sessions as well for the laboratory sessions.
Sorry, I don't know that.
So, we have to see how many lab sessions we actually need. Maybe one is enough, but I'm already sort of going to the idea that maybe I should be available for both. And we can also discuss some of the stuff that we discuss in the lectures as well. If we do that, it gives me a bit more time. I will upload screencasts of all of the lectures because I think that's going to be a very useful thing to you, first of all, to get your understanding, and secondly, it's very useful for revision. Just to let you know, I always work on slides pretty much up to the time I deliver them. So, if you do want to look at the lecture slides, look at the ones online because the other ones are probably out of date. Also, whenever a mistake is found, and I encourage students to let me know, send them to me, and basically I'll update that as well as fast as I can. Okay, thank you very much.